and welcome to another XenSpace. Thank you for joining me. I wish to continue with my review of New Scientists. So we're now reviewing the 2nd of January 2021 first issue for the year, number 3315, the 2021 preview. I know I've got a little behind, the fourth one is out already, but I'll try and catch up over the next couple of weeks. So the title of the leader article is Our Big Moment. How we reboot the world as the coronavirus pandemic dies down will be critical. So it's looking at how we come out of the pandemic in terms of what we do relating to the environment. It mentions that the UK, EU, Japan, South Korea, China and US have all committed to producing new plans to rein in emissions by 2030. And ends by noting that public pressure may well prove critical in making the politicians actually act on the plans they're producing. And I agree with that, and I'll return to that thought in later videos about politics. So the preview of 2021, I know 2021, begins with when will life return to normal? And this is a look at how long restrictions and lockdowns are likely to continue. The article opens, if 2021 felt hellish, be warned that we aren't out of the fire yet, even if we are moving in the right direction. Welcome to 2021, aka Purgatory. So that's I think a good way of summing up the situation. So their prediction is the effect of widespread vaccination will start to have an impact around April, and there'll be a further month or so of restrictions before the all clear is likely to be given. That, of course, is assuming the vaccinations can be carried out on the scale required as are effective as they are supposed to be from the test data. The article notes, though, that due to concerns over the efficiency of these vaccines, countries are ordering vast amounts. Now, these vaccines are supposed to require 2 doses for each person to be effective, to give them a high rate of immunity, not complete immunity, but you've got to take what you can in these situations. But because of that, because 2 doses might not be effective, and they don't even know how long the immunity as such will last. So some countries are buying loads in those. There's Canada has bought enough to vaccinate its population 5 times over. So one assumes that's 10 doses per individual. And the UK has enough to vaccinate its entire population twice over already, but it's still thinking about whether it might need some more. Now that might sound like you're just playing it safe, and the government's stockpiling to make sure it can deal with the situation. The problem here is there's only 8 billion doses currently allocated up to the end of 2020. And as I said, each person requires 2 doses. So if there's only 8 million doses, that's only 8 billion doses. That's only 4 billion people covered around the world. And if countries are buying up much more than they need, then that means the poor countries are going to be left without any. They won't be able to vaccinate their population. So that's not quite so good, is it? Right. Next we have an article on Mars. A swarm of spacecraft will arrive at Mars. There's a picture of a spacecraft there, if you don't know what one is. So it's about 3 separate missions from 3 different countries, all of which will arrive at Mars during February. So the first one to arrive will be the Hope orbiter, which has been launched by the United Arab Emirates, and that will observe and measure the Martian atmosphere. The next one is Taiwan-1, a Chinese mission consisting of an orbiter and rover. The rover's multiple sensors, including a radar system, magnetic field detector, instruments to analyse the Martian dust, and cameras. The final mission is NASA's Perseverance, whose prime directive is to collect samples to test them for signs of life, but also to store them for future missions which can come and collect the samples from the rover and bring it back to Earth. Pretty good. Say they're all arriving in February, so we should get the first data back from them in the next few weeks, or the next month or 2. Over the page we have just how harmful are these tiny plastics, looking at microplastics, well, even going beyond that into nanoplastics. And these once you get down to this kind of scale, they can enter cells, possibly even cross the blood-brain barrier, which is somewhat frightening, or horrifically scary is another way you could say it. But what does the article include? What are the risks and danger results as such? Well, not much really. It just reports that various lines of research are underway, some of which should get results in the coming months, others which could take a few years to complete. So basically it's watch this space. Next part of the preview is on climate change, but it's all covered that in brief detail during when discussing the leader, which referred to it. I won't go over that again. So I think it's time to move on to the, as the cover of this issue says, it's a special issue on the state of the universe. So this is a 7-page in-depth look at the universe, asking 7 questions. So let's go through the questions one by one. The first is, how old is it? Well, cosmologists have estimated, based on the universe's expansion, a possible range of between 12 billion to 14.5 billion years ago, which sounds fair. But then the article mentions that the oldest known star, Methuselah Star, has been dated to 14.46 billion years, give or take 800 million years, which would give it a range of 13.66 to 15.26 billion years old. And the article then notes that this could make it slightly older than the universe itself. No, it can't be older than the universe. I mean, it mentions a few lines previously to where it makes this statement that we know it's such an old star because it's made almost entirely out of hydrogen and helium, which were the only things around in the aftermath, of the Big Bang, shortly after the Big Bang had happened. So if it's made up of stuff that appeared after the Big Bang, how can the star predate the Big Bang? It's nonsense. Question number 2. How big is it? Well, astronomers have inferred from examining the expansion rate that the observable universe, that's the bit of the universe we can see, is 93 billion light years in diameter. So we can see around 46.5 billion light years in every direction. But how big is the whole thing? What answer do we get? No idea, basically. So some argue that it could be infinite. I don't see how the universe could possibly be infinite. If it started at the Big Bang, a finite period of time ago with a finite amount of energy, and has been expanding at a finite rate ever since. It doesn't matter if this finite rate is increasing, because if you increase a finite number by any other finite number, you end up with a finite number. Therefore, how could the universe be infinite? I just don't get it. If it had started out from the Big Bang and ended up infinite with a finite amount of energy distributed over an infinite amount of space, every quantum of energy would be infinitely far from every other quantity of energy. And that's just not how the universe is. So unless I'm missing something, I don't think it's infinite. It's just pretty darn big. Now, how fast is it expanding, relating to the question of how big it is? Well, we don't know how big it is, but if we can work out how fast it's expanding and work backwards, they say we can work out when the Big Bang happened. So I don't know why they can't use the expansion rate and so forth to calculate the whole size. But anyway, how fast is it expanding? Well, according to the Hubble Space Telescope, data collected from that, the current expansion rate is about 75 kilometers per second per megaparsec. What's a megaparsec? Well, it's a million parsecs, obviously. And a parsec is 3.26 light years. Or to bring back to the kilometres, the expansion rate is being measured in 30.9 trillion kilometres is 1 parsec. So a megaparsec is 30.9 million trillion kilometres. So that means that the expansion rate being 75 kilometres per second per megaparsec, it means that every second a distance of 30.9 million trillion kilometres becomes 30.9 million trillion and 75 kilometres, which is not a huge expansion rate, is it? Of that size, the amount it's increasing is 0.00000, but that's every second. So just thinking over the course of a year, It's going to add up. So there you go. But then there was another actually test done. An alternative measure was used using a different data set, and this gave a figure of 68 kilometers per megaparsec per second, which, you know, this sounds fairly close. It's only 10% out, sort of thing, but no, it should be, you know, they should agree much more than that. So scientists are shaking their head and wondering what's going on, so we don't know. How heavy is it? So next question, well, we do know, apparently, that normal matter is outweighed by dark matter 5 to 1. So for every tonne of normal matter there is, matter we find on Earth, there's 5 tonnes of dark matter out there in the universe somewhere. We don't know what the dark matter is, but, you know, we can see it's there based on its gravity. We can see the gravitational influence of this additional matter, which isn't actually dark. It's completely transparent. You can't see it. It doesn't react with light. So dark isn't quite the right word. Although we know that the dark matter outweighs normal matter 5 to 1, no idea what the, you know, weight of the universe is. I mean, we don't know what size it is. How are we going to work out how much it weighs? So that's that. Question number 5. What shape is it? I don't know how many people wonder about the shape of the universe. Well, there's basically 3 options. It's either spherical, shaped like a sphere, saddle-shaped, shaped like a shadow, or flat, so shaped like something that's flat. Now, according to the article, the standard model of cosmology assumes it's flat, but that is the assumption. But the results of a recent study suggests that a better fit for the data is that the universe isn't flat, so it's one of the other shapes. How many are there? Question number 6. Unsurprisingly, we don't know. There's no agreed answer here, no way to investigate the question, and different theories give us different answers, all the way from 1 to an infinite number, depending upon the theory. So take your pick. Question number 7. When will the universe end? Again, there's no way to find out the answer to this. All of our current predictions rely on assumptions about whether the universe will continue to expand at an ever-increasing rate, in which case the universe won't really end as such. It will just eventually be completely cold and empty as all matter gradually decays away through entropy, and a situation known as the heat death of the universe occurs, where it's just nothing. It's just a cold, empty place. Or it could just suddenly go through from phase change at any moment, you know, resulting in the laws of physics changing unpredictably, which would likely be catastrophic for everything in the universe. Matter might all be ripped apart, and the suns and planets just gone, just torn asunder, depending upon how the laws of physics change. But my favourite theory is that proposed by Roger Penrose, not mentioned here, that I recall, who says that the actual end conditions, or what other people consider the heat death, he says it's exactly mimics the phase just before the universe sort of began, the moment of the Big Bang, sort of just prior to that, if there was anything prior to that. So his prediction is that a new universe will spontaneously born out of the ashes of the old, so to speak, like the phoenix. You know, which I think is a nice image and a good theory. If you're interested, I'll put a link in the description about where he discusses this idea. A very, very clever chap and well worked out theory. So yeah, that 7 questions, only one really with an answer. The how old it is, and even there, some silly comment about things in the universe being older than the universe itself. There's not really a lot going on in that issue, but you know, it's the first issue for the new year. I just had the big bumper New Year and Christmas special, so you know, it was going to be a very slow news week around the time they were putting this together, which was probably actually just before Christmas or in the period between Christmas and the New Year. So you know, if there's no news, there's not a lot to report, is there? So and a lot of science is we're investigating. We've come up with a new idea, a new theory, or a new way of measuring data, a new way of analysing things. So we're going to try this out, and we'll come back and let you know what the results are once we're finished. That's the way science goes. So there you have it. And to not extend this any further, I'll leave it there. Thanks for watching. I hope you've enjoyed this, and until next time, take care. Bye.